Okay, so today what we're going to do is we are going to start a different type of factoring that I don't believe you've seen before. Yesterday we did factoring using GCF method, and we learned that you can take out a number and or a letter as well. Today we're going to factor something called difference of two perfect squares, and you're going to hear me refer to this as dots. Difference of two squares. So you're going to hear me say this word a lot because it's just an acronym for difference of two squares. So let's think about what that means. When I say difference of something, I hope that you think subtraction. And then when I say of two, that means subtracting two different things. And then subtracting two squares, or two perfect squares if you want to be more specific. Well, let's think about what are perfect squares. So one squared is 1, so 1 is a perfect square. 2 squared is 4, so that's a perfect square. 3 squared is 9, 9's a perfect square. 16, 25, 36, 49, 64, 81, 100, and 121. Those are all perfect squares. Now, I could ask you perfect squares greater than 11, or technically 121. I could ask you 144. I could ask you 225. So what you're really going to have to start recognizing is probably the first 15 perfect squares. Here are the first 11, but I would like you to try and start recognizing the first 15. So what are we factoring today? Well, we are basically doing the reverse, or we're starting the reverse of foiling. So remember when we learned foiling? To foil something, the FOIL, again, is an acronym, and it just helps us remember the order to multiply a binomial times a binomial. So the F in FOIL stands for first, so if I multiply the first two terms together, x times x gives me x squared. The O, it means I'm going to take the two outer terms and multiply them together, which will get me a negative 5x. The I stands for the inner two terms, so that's going to get me a plus 5x. And then the L stands for the last two terms, and that's going to give me a minus 25. And so when I FOIL these two things out, what I notice is negative 5x and positive 5x cancel each other out, and so that will simplify to an x squared minus 25. I'll come back to that in a second. Let's do the same thing for the next two factors. Y times y is y squared. Then I bring it over to the 7. Then negative 7 and y. And negative 7 and 7 give me a minus 49. And again, what I notice is these two middle terms are additive inverses and they cancel each other out. So I need you to start making some connections. Look at the two results we just ended with, x squared minus 25 and y squared minus 49. And I want you to look at some of similarities with me. Both of them start, at least in this case, with a variable squared. They are separated with a subtraction sign, and they end in one of our perfect squares. 25 is in our list, and 49 is in our list of perfect squares. Hence, the type of factoring we're going to do today. Dots, which stands for, again, difference, so subtraction, of two squares. I hope you agree that x squared is a perfect square, and 25 is a perfect square, and I am taking the difference of those two things. So that is what the problems are going to look like today. You're going to find that the strategy for these are very easy. So now let's take these two binomials that we just found by foiling and see how they relate to the original things that we multiplied together. So if we look at the original two factors that we multiplied, x plus 5, x minus 5, that is what we're going to end up as our results today, because we are going, remember, in the reverse direction of foiling. Well, I hope it makes sense that 5 and 5 is going to produce a 25, and in the second example, 7 and 7 is going to give me a 49. So you might see some things in those two factors. So where it says difference of two squares, you must have a binomial where each term is a perfect square. They must be separated by a minus sign or a subtraction sign, whatever you want to write. Okay, and the way that we are going to factor them is basically we are going to take the square root of each of these two perfect squares. So we are going to square root both of our perfect squares. And how we're going to write our answer is you're going to put the same results in both bubbles. Okay, and one of our bubbles, I call them bubbles, but they're really technically factors. One factor is going to get a plus sign and one factor is going to get a minus sign. It does not matter which factor you put the plus sign in as long as one gets a plus and one gets a minus. So if you look at the two examples that we foiled out up at the top here, one of them in the first example, we had a plus sign in the first one and a minus sign in the second one. And in the second example, we had a minus sign and then a plus sign. So the order did not matter. The result will come out the same. So very, very easy strategy and procedure today. So very first example, starting off nice and easy for us, okay? And you can always check your answers. So once you have it factored, if you're not sure if it's correct, you can just FOIL it back out and see if you get the original problem back. So we want to take the square root of both of these. We're going to end up with a result of 2 binomial factors. So I usually kind of like prep it by setting up my 2 sets of parentheses. And if I square root x squared, I get x times x is x squared. And then I ask myself, what times what is 4? And remember, it has to be a perfect square, so it has to be the same factor going into both of my 2 bubbles here. And then the rule is one of them gets a plus sign and one of them gets a minus sign. So I'm not going to check all of these. I'm probably only going to check maybe 2. And this will be the first one just because it's our first example. And then I'm going to check actually number 4. So when we get there, I'll check that one too. So to check, all you have to do is FOIL this back out. So I'm going to use a different color just so that you can see the difference between what our answer was, which will be blue, and our check, which I'll do in red. So if I FOIL it back out, what I'm hoping to get is the original problem. My 2 middle terms cancel and I get x squared minus 4, which checks out to the original problem. So remember, the blue answer is my actual factored answer. I was just checking in red. It's that easy. So let's take a look at number 2. I'm going to set my space and do my sets of parentheses. The square root of y squared is going to be y times y is y squared. 9 times 9 is 81. One of your factors gets a plus sign and one of your factors gets a minus sign. Final answer. Hopefully you're thinking, I got this. This is easy. So number 3, again, very straightforward. Both of those are set up perfectly. They are perfect squares separated by a minus sign, dots to a T. So b times b is b squared. I know my b's look like 6s, so sorry. 16 is 4 times 4. 1 gets a plus, 1 gets a minus. Done. So number 4. It looks a little backwards to me. Unfortunately, you have to leave it in this direction. So we learned early on in the year, probably like the first day of school, that the commutative property only works for addition. Obviously, this is difference of 2 squares. So if it's a subtraction sign, I cannot rearrange this order. So this is where order is going to be very important. So when I set up my 2 sets of parentheses, in these factors, if the number comes first in the original problem, then in my factors, the number has to go first. What times what equals x squared? Well, that's going to be x times x. And then again, 1 gets a plus sign, 1 gets a minus sign. Now, I told you I was going to check this one. I'm going to check this one because the answers look funny. So I want to check it and prove to you that the number has to come first. So if I FOIL this out, and again, I'm going to use my red color just to show you the difference. All right, 7 times 7 is 49. minus 7x plus 7x, and then x times negative x is going to give you a negative x squared. I tell you, my juniors still get this one wrong. If the number comes first, the number has to go first in the factor. So this is technically your two factors. I was just checking it again in red, and it checks out. So order matters because one of our factors has a subtraction sign, so you have to put the number first if the in the original binomial the number comes first. All right, I think I'm safe to skip number 5. If you want to do it on your own really quickly right now and try it, that's fine. But I want to take a look at number 6. So we're stepping up the difficulty level here. Take a look at number 6. So 4x squared. Remember, dot stands for difference of two perfect squares. If I look at 4x squared as its own thing, I hope you agree that 4 is a perfect square, x squared is a perfect square, and 25 is a perfect square. So when I set up my two factors, I have to think to myself, what times what will give me a 4x squared? And it has to be the same thing in both bubbles. So I hope you agree that 2x times 2x is 4x squared. The second half of this, 5 times 5, that's the easy part. One gets a plus sign, one gets a minus sign. There's your final. So let's step up the difficulty a little more. 16x squared. If you take a look at that number, I hope you agree that 16 is a perfect square. I hope you also agree that 49 and y squared, those are all perfect squares across the board. So when I set up my two factors, what times what has to be the same thing twice, multiplies to 16x squared. Well, both factors would have a 4x times a 4x is a 16x squared. And then what times what will give you a 49y squared? That will be a 7y and a 7y. One gets a plus, one gets a minus, done. All right, so number 8 doesn't look great. And the reason why is because remember, this type of factoring that we are doing today is called dots. Difference of two squares. This one, unfortunately, oh, well, that looks bad, but I tried to circle the plus sign. This is not factorable. Not factorable because of that plus sign. There is nothing that will be two factors that will FOIL out to give me a squared plus b squared. At least not in your freshman year this year. So if that ever happens and you can't factor something, you can write not factorable. However, I'm sure someone out there will think it's funny and they're just going to write not factorable all over their homework. Obviously, I want to have you practice this, so trust me, they are going to be factorable on your homework. So please don't write that or I won't give you credit for the homework. Now, what would be factorable if I had a squared minus b squared? That would be factorable. So even though there are no numbers in that expression, in that binomial, we can still factor it. So if you write that one in, think what times what is a squared? Hopefully you all think a times a. And what times what is b squared? That would be b times b. One gets a plus, one gets a minus, and that would FOIL out to give me a squared minus b squared. All right, the difficulty levels are increasing. So let's take a look at number 9. 25. If you look at the top of the, or well, technically the last page, if I scroll up, that is on my list of perfect squares. 121 was actually the very last number on my list of perfect squares. X to the 6th power and x to the 4th power. We haven't dealt with anything higher than an x squared yet. But use your properties of multiplication. When you multiply, you add your exponents. So we all know this is going to be 5 times 5 is 25. But x to the what power times x to the what power will add to a 6, 3, and 3. all you are doing, if it's an even exponent, is cutting it in half. Now, technically, yes, there was a GCF in this problem that I probably should have taken out first, but I want to practice these higher exponents because we'll have to know how to do them for number 10. So I just want to show you how to split an exponent. So this 6, all you are doing is cutting it in half. So that means for the 4, I'm kind of going to use the same property. So 121 is going to give me 11 times 11, x squared times x squared. You add your exponents. So when I FOIL that out, it would give me an x to the 4th. All right, number 10. If I go right to my double bubbles, my 2 sets of factors, 36, a to the 4th, b to the 6th. Don't get overwhelmed with how many terms or how many things we have to factor. Take it one step at a time. Split the 36. Remember, it has to be perfect squares. So 6 times 6 is 36. Now let's focus on the a to the 4th. I need to split that up to be a squared and a squared. Our factors are going to be identical. They just have one has a plus sign, one has a minus sign. So now our B3, I might not have left enough room for my pen here, B3. Move on to the other half of this problem. 64, what times what is 64? 8 times 8, x times x is x squared. I'm going to squeeze this in, y to the 4th and y to the 4th. One gets a plus sign, one gets a minus sign. So if you just take it step by step, and then you won't get overwhelmed. Okay, fractions are usually something that makes people really nervous, but take a look at this fraction. 4 is a perfect square. 25 is a perfect square. T squared is a perfect square. So the way that you're going to factor this, t times t is t squared. Split 4 and 25 by taking the square roots of them. 2 times 2 is 4, and 5 times 5 is 25. One gets a plus and one gets a minus. So you would do almost the exact same thing in number 12, except my rule, if the number comes first, then it has to come first in the factor. So 9/16. I need to split that by taking the square roots of each of those two numbers. So 3/4, 3/4, because 3 times 3 is the 9, 4 times 4 is the 16. Split the 25 now, so 5 times 5 is 25. Z times z is z squared. One gets a plus, one gets a minus. So even something like number 13 that looks a little overwhelming, just take it one term at a time. So I'll kind of like give you a couple seconds to get a head start, and then I'll write in the answer and you can kind of see how you did. So, you know, playing the Jeopardy song in my head here. Okay, probably gave you enough time. It doesn't take too long. 1/8/9y, 8/9 y. One gets a plus, one gets a minus. So hopefully you got 6/7 x plus or minus 8/9 y. Now for number 14 is not dots. And if I was there, I would say, why is it not dots? And hopefully you would say, there you go, not dots. Remember, dot stands for difference of two squares. Well, this is not two things. This is a trinomial, not a binomial. So this can't be dots. Actually, 16, 4, and 10 are all divisible by 2. So actually, this is technically GCF. This goes back to what we did yesterday. So 2, if I take a 2 out of everything, 8x squared minus 2x plus 5, and still it's not dots, it's still a trinomial that's left, and that would be my final answer. Sorry, that's just my dog growling. And actually 15 is not dots either because that plus sign ruins it. Rika, Hey, come here. Sorry, guys. Oh, shh. I'm taking a video. Okay, we have 2 questions left. All right, if the area of a rectangle is expressed as the following binomial, then what's the product of the length and the width? Shh. So area is length times width. Rika, stop. Hey, come here. Sorry, guys. So area of a rectangle is expressed as x to the 4th minus 9y squared. Now, obviously, I put that on this lesson, so there's a reason why I'm including it in this lesson. Clearly, we're going to have to do some type of factoring. Now, if area is length times width, then that means I need to basically figure out what times what equals this expression. And so to do that, we now know how to factor, and so here's what we're going to do. We're going to factor that and find out what the length and the width could be represented by. So if I'm going to factor x to the 4th minus 9y squared, I hope you agree that both of those things are perfect squares. So when I factor it and I set up my double bubbles or my 2 factors, what times what is x to the 4th? That would be x squared and x squared. And then you ask yourself, what times what is 9y squared? Well, 3y times 3y would give me 9y squared. 1 gets a plus, 1 gets a minus, and that's going to match option. Oh, sorry. I messed up. Let's go back to my pen. Number 2 matches option 2. All right, last but not least, and there are questions like number 17 on your homework, which is why I need to do this one as well. It says express the area of the shaded region. So to find the area of the shaded region, I basically have to find the area of the large square and then find the area of the small square, and then I need to subtract that small like white triangle away from the large square. So basically I'm doing the large square minus the area of the large square minus the area of the small square. So area is length times width. Well, that's good because the length and the width of the large square, which is why I kept calling it a square, is 2x times 2x, which is 4x squared. The area of the small square is 5 times 5, which is 25. So my answer to part A would be 4x squared minus 25. Well, look at that. Odd that I would put this on today's lesson because now it says what is the product of the 2 binomials. So product of 2 binomials is just a really, really fancy, confusing way to say, hey, factor by dots, because 4x squared and 25 are all perfect squares and it fits perfectly in today's lesson. So the product of the 2 binomials would be 2x plus 5 and 2x minus 5. So that concludes our lesson for today. And I will be back tomorrow